On behalf of RBCS, RBCS New Zealand, RBCS Australia, and Software TestWorks, we welcome everyone today to this webinar on Advanced Software Testing with Domain Analysis. I'm Rex Black, President of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States, New Zealand, Australia, and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with a measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I'm the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and very soon 3, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in Computer Science and Engineering from UCLA. I'm also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. Before we start the presentation, a couple housekeeping notes. If you have any questions during the course of the webinar, please submit them anytime during the presentation via your webinar interface. There is no need to ask for presentation copies. The presentation is posted on the web, www.rbcs-us.com, on the Basic Library page of the Resources tab. If you're having problems with either the audio or visual components of this webinar, please contact GoToWebinar support. We are not able to directly debug GoToWebinar problems. If for whatever reason you cannot get to the webinar online, or if you're dealing with an unreliable connection, then please download the slides. As I said, they are at www.rbcs-us.com. Go to the Resources tab and select the Basic Library. You'll find them at the bottom. And then use the telephone to connect rather than voice over IP, and you should be able to follow along just by the phone. Hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. Today's presentation is part of an ongoing series on advanced software testing. We'll keep doing these for a while. Haven't decided which topics come next after this one for sure. Material so far for these has come from my popular books, Advanced Software Testing Volume 1 and Pragmatic Software Testing, and with Advanced Software Testing Volume 3, which is more technical and white box stuff, we'll probably shift over and spend some time looking at some sophisticated white box testing techniques here in the next 2 or 3 of these. Probably keep this going for another, at least in 2011, and maybe we'll stretch it out into 2012 if the interest continues. We do have a lot of people signing up, so happy to keep talking about advanced software testing techniques as long as people are happy to listen. Today we're going to talk about domain analysis. Now, I chose to do this series of webinars on advanced software testing because there are a lot of powerful test design techniques that have been developed over the last 30 years. But a few of these techniques are really in use, and that's a shame. I think in a lot of cases people just aren't aware of the technique, or they don't know how to use it, or can't identify situations where they can use the technique. So this series of webinars is hopefully helping people address those issues and bringing more application of advanced software test techniques into the day-to-day world. Okay, so on with the presentation. So we looked at in sort of basic testing training courses. You've probably seen this, or you've seen this in my books, or heard me talk about it. It's sort of basic test design techniques, equivalence partitioning and boundary value analysis. And those are useful for testing input field validation. So you're checking to make sure that things that should be accepted are accepted, things that should be rejected are rejected. But as this series of webinars has really been pointing out, that those at least immediately are not what you typically want to use to test the business logic of the system. And of course that's where the really interesting test cases are, right? I mean, it's it's all well and good to make sure that that input validation works properly, and certainly there are security risks associated with improper input validation. But your functional problems are going to typically be down in the business logic, and we need some way of testing it. So domain analysis is one way of doing that, and it's actually, and I'll get to this later, something of an extension of boundary value analysis and equivalence partitioning. But if you don't see the similarity right away, don't worry, I'll explain it later during the Q&A. Okay, so one of the fundamental problems is in testing is the combinatorial explosion problem. So you start off with some factor that has a limited number of options associated with it, and that's fine. From testing it, it's not that hard. You think of, if I've got an input field, and it's basically got 3 equivalence partitions associated with that input field, and each of those has a boundary value, then I've got 6 values, right? A minimum and a maximum of each of the equivalence partitions, assuming it's an ordered set. And maybe you've got a few other possibilities like throwing non-integers or whatever, stuff that's just clearly invalidated. And so, you think, okay, well, that's not so bad, and you can, as you know, if you know the technique for generating tests with equivalence partitioning boundary values, you combine valids together, so whichever one of your sets, whichever one of your options has the most number of, or whichever of your factors, excuse me, has the most number of options is going to pretty much determine the number of valid tests. And then you look at invalids, and the number of tests remains pretty straightforward, but all you're really doing there is testing, as I said, the input validation. To some extent, you're testing business logic, but you're not testing interaction of the inputs that you're entering so much. You're not looking at the interactions of them. So that's a potential problem. But if we say that we want to try to test out all the possible combinations of the equivalence partitions, or if applicable, the boundary values, then this number gets really big really fast, because if you assume you have 6 possible test values for each of these input fields, let's say, and you've got 10 input fields on a screen, then the number of combinations is 6 to the 10th, 6 times 6 times 6 times 6, et cetera, all the way out to the 10th power, and that's a huge number, and this is just a test on one screen. But when you see a combinatorial explosion, the first thing to do is back away from it, because it usually indicates that you've gone down some sort of blind alley and you're trying to test something through brute force, because ultimately that's what, if you were going to test all the combinations, ultimately you're saying, I can't be bothered to figure out what's going on here, so I think I'm just going to brute force it and test everything. And then the combinatorial explosion is going to defeat you. So when you see a combinatorial explosion, as I said, back off and do one of 2 things, or determine one of 2 situations that applies here. If you've got factors that are present on a screen or in a set of inputs or outputs or what have you, and these things have to interact properly. In other words, there's a defined way for the values to interact, and you need to test that, then test that. If there is no defined way for the factors to interact, they're not supposed to interact, but they might, and that if they did, that would be a bug. Then what you're going to do is you're going to use a technique like orthogonal arrays or other pairwise techniques, which were discussed in a previous webinar. If you missed that webinar, by the way, you can go out onto the digital library and catch that recorded pairwise testing webinar. It's also on YouTube as well. I'll discuss that a little later. Anyway, so to just recap this, if you're dealing with a situation where factors are not supposed to interact, but they might, and this is pretty much the usual situation with any sort of